Hello everyone, I am Ishan. Today we will be continuing our series of ML Study Jams 2024. Introduction to Linear Regression with a Real World Project is our today's topic basically. This session would be led by Tisha ma'am. So, for those who have joined, if you face any kind of issue, then just let us know in the chat section so we can figure it out. Now, I would like to hand over the session to Tisha ma'am. You can continue, ma'am.
Yeah, hi everyone. Sean, can you just confirm if my voice is audible and clear? Okay, then let me share the screen for today's session. Can you just confirm if my screen is visible? Ishan, can you please confirm if my screen is visible? Okay, thank you. Okay. Okay, so hi everyone. Good evening to one all present here. Welcome back to the ML Studies Jam series that we were continuing. So, due to some of the other reasons, we had one of our offline event as well, and we had some of the other commitments, due to which we had to stop the series for a month. And here we go. We are back with another yet amazing session. So today we are going to deal with linear regression, and we the very normal basic project that is very famous for linear regression. So let's start off with the session, and I will just let you know that if you have any kind of doubts, any kind of technical issues that you are facing right now, so you can just text off in the Discord, and maybe one of our team member or me will look into it. I hope the guidance are clear to each and every one of you. Okay, so let's start off with the session. So, what is linear regression basically? So, a linear regression is a statistical method used to model the relationship between dependent variable and one or more independent variable, basically. So, before we get more deep into linear regression, there is a very basic information that I would like to convey. Like people get this question a lot in the interviews or maybe some of the other examinations, and they actually are unable to answer, who are very new to ML. Basically they are unable to answer such questions, which is what is difference between regression and classification. So there are regression algorithms as well as there are classification algorithm. So linear regression is of course a regression algorithm. There are other regression algorithms as well we can search out. So basically, regression is where you are modeling the relationship between two things, right? And when we talk about regression, and when we talk about classification, it's like you are classifying things based on some of the other features, maybe some of the other variable, maybe some of the other difference or aggregate function if you're using so. So it depends what thing you are using to do the classification. The basic example of classification that I can give you is most of the people are using Netflix, right? So in Netflix we have different genres, and that genres are actually that can be classified using a normal classification algorithm, any of the classification algorithm that you choose from, which suits you the best, so which you think would be very easier to deal with the data that you're dealing. So you just use algorithm and you actually classify various things. Maybe it's like you classify on the basis of if it's a horror movie, if it's a comedy movie, if it's a if it's a maybe a thriller movie. There are a lot of genres you can pick from, and you classify based on certain features, certain words that are written in the information of the basic information about the movie. So this is how things work out when we talk about classification. This is just a basic example of classification. So let's now deep dive into linear regression. So here, it's like we are creating a relationship between a dependent variable, and the independent variable can be one or more than it. It assumes a linear relationship between the independent variable. So, independent variable here we talk when we're talking about independent variable. Here, whenever we are going to talk about independent variables, so that will be features. So, features are like already there. Of if we pick any of the product, let's say we pick a bottle. So, if product name is bottle and it already had a features which is black in color maybe, and it's a steel bottle and it has a height of let's say 50 centimeter. So it's like normal features which are independent of any of the thing. It's like a built-in product, right? So when we talk about dependent variable, it can be it's like basically target. So like in the end of the session we are going to build a project a linear on linear regression, which will be house price prediction. So there are features of the house and we are going our target will be to predict the price of that house, right? So this price is actually going to be dependent on the what are the features of the house, right? So that is going to be considered as a dependent variable, that is going to be considered as a target basically. And when we talk about independent variable or the features, that will be in the terms of house, that will be maybe the previous costing of the house, or what is the age of the age of the house, what are the what kind of dimensions it is having. So all these things will be independent variables when we talk about this case. So, what are the applications of linear regression? So, there are many more applications you can talk about, but basically, the main one are the three, which is like predictive modeling, trend analysis, and forecasting. So, predicting modeling means you are going to predict some or the other things. The looking into the taking out after taking out the relation between two things, you are going to predict what the future can be. Trend analysis, basically whatever the past trends already has been, analyzing all those things, you're going to predict the future. So that is basically working on the trend wala data. Forecasting. Forecasting is, I guess, when we always talk about difference between supervised learning and unsupervised learning, you always get the example of forecasting, weather forecasting. So this is also application of linear regression. So let's start with the understanding the basics of linear regression. So there are two types of linear regression. One is simple linear regression and multiple linear regression. So you know the linear equation, right? Y equals to mx plus c. So what is there? Y, what is y? Y is a dependent variable and x is the independent variable. Similarly, uh, linear regression works. So when we talk about simple linear regression, it involves only one independent variable, like here in this equation, linear equation, which is y equals to mx plus c. Here you can see there is only one independent variable, which is x. M is the slope, c is the constant or the intercept, as usual. And when we talk about multiple linear regression, it involves more than one independent variable. Like here is mx plus c. It won't be mx plus c when we talk about multiple linear regression. So what it will be? So you can see the equation, which is y equals to b0 plus b1 x1, b2 x2, and that will go up to bn xn, let's say. So here what y is of course the dependent variable, x1, x2, xn are the independent variable, and b0, b1, bn all are just new, maybe might be new to you. So these are the coefficients, which is like interpreting coefficients. Like what they are going to do is like they are going to represent the effect of each independent variable. What is independent variable? They are going to affect independent variable is here is it is x, right? So x1, x2, all this are independent variables. So what is the effect of this independent variable on the y, which is dependent variable, right? So I hope this basics is clear to each one of you. If any one of you have doubts, you can just uh, text in the Discord, or else let's move on to the next topic. So let me give you the overview of this session today. So I forgot to do that earlier. So, okay. So in the we have some of the other queries from the last sessions that it was quite sometimes getting of a lot of it was taking a lot of time. So we have reduced the timing for each session, and today we'll try to cover till 7:30. We have started from 6:30 and maybe 10 minutes up late. Maybe so. We will try to cover up things by 7:30, and what we'll be covering is like a basic theory of linear regression, then some of the steps that you can follow to implement linear regression, and then at the last there will be a very basic model that you will be creating to predict the house price prediction. So this theory is actually for you to, if you are there are any kind of theoretical questions that come into examination of your semester examination, so you can tackle with all those things. Okay, so let's start with where we left over. So next topic is model evaluation. So after applying the linear regression, you need to evaluate what model that you have built in. So what evaluation means? How good our model is, how bad it is, how much error it can give. All kind of things can be considered as a model evaluation. So mostly what we use is these three things. First is coefficient of determination, which is termed as R square. This represents the proportion of variance in the dependent variable that is predictable from the independent variable. So the range of this is from 0 to 1, and if this is more, if it's better if it's more. And when we talk about mean squared error, I hope people who are already into machine learning are already maybe have heard some or the other way. They have heard about MSE, which is mean squared error. So it measures the average of the squares of the errors, or mostly termed as residuals as well. So of course, if the MSE is lower, that is a better fit. So of course, R square should be more and MSC should be low. Adjusted R square penalizes complexity to prevent overfitting, adjust for the number of predictors in the model. So we have till now not covered overfitting and underfitting. Most probably that is going to be covered in the next session in detail. So you can just come up back to this collab link. That of course this collab link is going to be shared with each one of you. And you can come back to this collab link and just iterate over what you've learned from what overfitting is and what underfitting is. So for now, it's like very basic. You can understand that it's dealing with the overfitting that the model has. Later, you will be deep diving into what overfitting is, what underfitting is in the next session. Now this is a theoretical thing. If it comes, what are the process of linear regression? What are the steps you follow while building a regression model, a linear regression model? So this is a theoretical thing that you can write up. So first is like what's the building and first step is basically the building and training the model. In that we have data pre-processing and training the model. So basically data pre-processing, you all know that we have already covered when we're dealing with pandas, we were dealing with NumPy. That at that moment also we have covered data pre-processing and then other things that we have covered. I hope you all remember them. But if not, you can still go through with the collab link or the resources that we have shared through, I guess, from through GitHub. We have, I guess, uploaded all of the resources in the GitHub repository of us. So let us know if you need any kind of help in the same. So when we talk about data pre-processing, handle the missing values and code category variable, if any, split the data into training and testing sets. I, I hope you all are aware about you know the difference between training and testing. So basically, training is like what data you're using for training the model, and there are the other data that you will use for testing the model. So you are going to train um, a category of data to the model and the other category for testing if it is working or not. So make sure both of them are not same, they are different. The training data should be different from the testing data, so that you can check the accuracy of your model that you have created. Now comes the model interpretation. As mentioned before, that B0, B1, when we are talking about multiple linear regression, B0, B1, Bn are like coefficient which helps in interpreting, which are interpreting coefficients. So this represent the effect of each independent variable on the dependent variable, holding other variables constants. Secondly, we have making predictions. So once the model is trained, use it to make prediction on new data. So of course, like the data, as I said, the data should be different. So here's a practical example uh, that you can use. Uh, so data set overview, data exploration, visualize the relationship between independent and dependent variable, model training, and evaluation, like splitting data into training and testing sets, and the lastly there's interpretation. So here's the here's the data, here's the basic code of whatever we have discussed through. So here's the basic code of what linear regression can, how we can work upon linear regression. So, firstly, we are like, this is a step one. We are importing necessary libraries, which include NumPy, Matplotlib as pyplot, matplotlib.pyplot as PLT, sklearn.model selection. So you are, I guess, aware about NumPy and matplotlib.pyplot because we have to use this both of them in our earlier sessions. NumPy is a library for numerical computation, especially useful for handling arrays and matrices. And when we talk about matplotlib.pyplot, so it's a basically plotting library for creating interactive visualization in Python. And train test split is like a function of scikit-learn that splits data into training and testing sets. And when we talk about this linear regression, it's a class from scikit-learn used to perform linear regression, basically. So these two main functions that we have, uh, these are new to you, I guess, because we didn't cover linear regression earlier. Now the second step is to generate the example data. So this np.random.seed like this is used to set the seed for the random number generator to ensure reproducibility of the results. And when then we have x equals to 2 into np.random.rand 100 comma 1. So it's like basically generating 100 random numbers uniformly, and it's going to be distributed between 0 and 2 for the feature x. So x was dependent, right? So x is, sorry, independent, right? So x is independent. So features are independent. So that's why here we are. Um, uh, that's why here I referred x as a feature. So y is a dependent variable, which can be termed as the target. So 4 plus 3 into x plus np dot random dot rand and 100 comma 1. So this is actually generating the target variable y using a relationship with x plus some random noise. So the equation used here is like y equals to 4 plus 3x plus noise, you can say. Then we have the third step. Let me just quickly run over the score. Meanwhile, guys, if you want, I would share this link, collab link with you right now on the Discord, so that you can just copy the code and try running these codes in your system. Let us know if there's any kind of issues you are facing. Okay, someone has texted. Can we get their formulas? What formula we're talking about? Can you be precisely telling me so that I can answer your query? I guess you were. I guess you were asking about the collab link only, so that you can try out this formulas or code, whatever. talking about R2 and MSc. Okay, yes, sure. So later on in this session, you are going to get deep information about what R square and MSc is doing and what is the formula of it. So no worries. We'll deal with it. Okay, so the third step is to visualize the data that we have done. We have actually generated the random one. So here is like plt.scatter. So it's creating a scatter plot from the of the data points. X label, Y label is basically mentioning the label that you want in the plot that you're creating. So if there is anything else you want, and you can create, like here we are labeling it as an independent variable X and Y label as dependent variable Y. You can also, if you're doing in some or the other type of visualization, you can mention that what X axis is representing and what Y axis is representing. PLT title is the title for the whole plot that you are generating, and PLT.show is displaying the plot basically. So um, here's the plot of the dependent variable y and independent variable x created out of the random data that we have generated. So um, I hope you guys don't have further doubts. Let me know if there's any. Uh, I'll move forward with the step 4, which is like splitting the data into training and testing sets. So we are having X train, X test, Y train, Y test, and that is equal to train test split. So this is the function that we have introduced from scikit-learn, and we in this method we are passing x, y, and test size equals to 0.2 and random state equals to 42. So this actually function is what it's doing is splitting the data into training and testing sets. So 80% of the data is going to be used as training, and 20% of the data is used for testing. And that's why it's like test size equals to 0.2, mentioning that 20% of the data will be used for testing. This random state equals to 42 ensures the split is reproducible. To understand this, and let's the next step, which is step 5. Let me run this code first. And this one. Um, case. So this fifth step is to train the linear regression model. So how we're training is like we are firstly creating a linear regression object, instance of the linear regression class, and then that this is model.fit xtrain ytrain. So trains the this is going to train the linear regression model using the training data, which is xtrain and ytrain that we have splitted into the step 4, right? So the step 6 is to predict. Um, so step 6 is making the prediction. So this is y pred. So y is, as we have already figured out, y is dependent variable, which is target. So this is what we are going to predict, right? So y pred will be equal to model dot predict x test. So what we have um, the x what data which is left for x as a testing will be used for predicting the y. So this is basically using the training model to make predictions on the testing data, which is x test. Then we have the seventh step as visualizing. So plt.scatter, which is again actually going to create a scatter data. And then we are plt dot plot x test y red color red. You can specify any other color as well. Here I've specified it as red. Label will be regression line. Plots, this is going to plot the regression line using the testing data and the predicted values basically. And then we again have x label, y label. And the title here, we have changed the title to simple linear regression. Then we have plt.legend. So legend is basically this thing you can see on the plot. So here we are specifying what type of things we are using in this plot to make the user understand what it is like. Then we have, of course, plt.show. Lastly, so you can now see linear regression line uh, between the scattered step, which is to end up basically evaluating the model, which include r square, taking out the r square and the mean value, mean square error. So what we are doing is like print intercept comma model dot intercept. So this actually prints the intercept of the linear regression model. The intercept is the value of y when x is 0, and when then we are printing coefficient model dot coef we are using. So this is going to print the coefficients of the linear regression model. The coefficients represent the change in y for 1 unit change in x basically. So, and then we are actually having r squared. This is r squared, like it's actually calculating the r squared value for the model. And r square, as it discussed, is a measure of how well the model um, basically explains the variability of the target variable, I would say. So it ranges from 0 to 1, and with higher value, of course, that it indicate the better fit. So here you can see what is intercept, what is coefficient of the model that we have created, and then you have the r squared being printed over here. Now let's jump into a very basic model of predicting the house price. Let me again run over this code if you want to see, guys. Yeah. So here's the house price prediction. So so you can just look into like what libraries we have here. Just this one more thing, which is sklearn.metrics.mean squared error, comma r2 score. So these are the functions to evaluate the performance of the regression model basically. And then we have this is, which is square feet, bedrooms, age, price. So age here is basically from how old the house is. Like it is built 10 years earlier. It is how, like, basically, yeah. I hope you understand this age of the house. What age of the house means here? It's not age of any kind of person over here. So square feet is the size of the house, and this is number of bedrooms. This is the price of the house. So here we are taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 data values as of now. Then we are here creating a data frame. I hope you guys um are aware of what data frame is. Panda's session that we took. I guess it was third or fourth session of us in the series. The videos is already uploaded, and you can find the resources as well. Okay, so yeah, creating the data set, data frame, and then we have this features and target variable. So X is, of course, the features. So here we have features as square feet, bedrooms, and age. We are just defining it. And Y is series containing the target variable price. Then we are splitting the data, X train, X test, Y classifying each and everything. This is again what it is doing is it's test size 0.2 means 20% of the data is used for testing, and this random state for 42 ensures like reproducibility of the split. creating and then training the model, which include model equals linear regression, which is going to create the instance of the linear regression model as discussed. And then we have a model dot fit x train y train, which is like training the model using the training data. Then of course making the predictions, which is y pred equals model dot predict x test. And then we are okay, making prediction, and then we have evaluation of the model, which is we are taking out MSC and R2. So what is MSC as discussed is mean squared error, which is going to calculate the uh, mean squared error between the actual and predicted prices. R2 score is between y test and y pred, of course. So it is going to calculate the R squared, which is coefficient of determination, to evaluate the goodness of fit of the model, we can say. And then, of course, we are going to print out both of it, right? So I hope you guys don't have doubts till now. If any, please let us know. New house equals to np dot array. Let's say there is any kind of new house having 2,500 of square feet as a size of it, and bedrooms are 4 and 5. It is 5 years of old. So what will be the price? So we are giving this data into the our model that we have created, and then you can see the what the output is. The output is that let me run over this code once again. You can see the output. The mean squared error is 3.3, R squared is 1, and predicted price for new house is 50, I guess 5 lakhs, sorry. Yeah. So the predicted price for the new house is 5 lakhs. I hope you guys are running over all the codes that I have shared you. I hope you guys can access the collab link. Okay, so we have a question which says, what is the importance of random state variable? Um, So basically, random state variable in machine learning specifically is particularly in the is actually in the context of functions like train test split that we have used from the scikit-learn library. It actually plays a crucial role in ensuring the reproducibility of your results. Reproducibility means like a consistency of results, you can say, or comparability also. And also it actually has control over the randomness. I am talking about splitting the data. What exactly splitting the data, like I guess I've explained how we are splitting the data. What is the point of assigning 40 to it? 40 to it? What exactly you're talking about? Okay, okay, got it, got it. Still typing something. Hmm. Okay. When I talk about 42, we are assigning it 42 because that's a very popular choice among programmers and data scientists as a convention. It's actually is arbitrary and it does not affect the randomness quality, right? So you could use any integer value. The key to use a fixed value for um, reproducibility, basically. So you can choose any value. It's just that 42 is mostly preferred by programmers. That's why we are using 42. I guess it's based on some of the other theory. Uh, I am not well versed with what history the 42 holds, but there's some kind of history behind it related to maybe some of the other scientists. Yeah. Do you still have any kind of doubts? Please feel free to ask. Okay, so no doubts till now. Um, okay, then I hope you guys learned a lot of things today. I'm still there for 5 minutes more. If you guys still have any kind of doubts, we sooner than expected, just because our earlier sessions were very sometimes got a bit late because of the doubts and the discussions that we had. But I hope this kind of session, a small session that have covered a topic like linear regression in such a short period of time is beneficial for you all guys. Sure, we are going to upload the collab doc in the GitHub by the end of the day or by tomorrow. So you guys don't have to um type all the code and you just have a reference to it and you can just copy paste and try running over each one of it. So we have shared the collab link right now on the session. Okay then. Guess there's no other doubts, so we can wrap up today's session. Thank you everyone for joining in. We hope that you got a lot of information from today's session, and hope you will meet you guys tomorrow evening, for yet another exciting session on the other topic. Thank you once again. Have a good evening.